So today's question was, rotate this image clockwise by 90 degrees about point P 3 times. So how did you do it? Let's share some answers, because I saw a couple strategies out there and I saw some mistakes. So I wouldn't mind sharing some of the mistakes first, the misconceptions. So if anyone's brave enough to share a misconception, I'd be more than happy to have you up here. So keep in mind, this is a misconception, and this is a common misconception with rotational geometry. So tell us what you did first.
Okay, so I knew, like, on the picture that Mr. C drew, this is how the shape looked, and point P was lower, but I thought it should have been on the shape. So I connected the shape to point P, and I drew all of these shapes on point. Fixed my mistake, and me and my partner, we saw that it was actually 2 boxes away from point P. And then what we did, how we got this is, we know that point P, we saw that this line is on this vertice, so, and it said 90 degrees, so we found a 90-degree angle, and wherever it ended, so 2 blocks away, we drew it. So we drew that this would be point P, so we drew this vertice and this like this angle basically, and then we connected it, and we did it all 3 times to make it to here. And that's how we did it.
Looks great. So I like how you shared and told us that your misconception was that you labeled the P on the actual point, even though it says it in the diagram, that it's not on the point. The point is not on the shape. So the turning happens outside. That's the key thing here. Okay? When it is like this, it becomes a little bit trickier, because the old way was putting your finger on the point and then turning it. It becomes much easier to visualize. However, outside the point becomes a little trickier. And the tricky thing is, I asked you to do was draw it out like this. Whereas I could have given you the shapes and asked you, is this properly rotated? So your task today was definitely not an introductory lesson. I wanted to challenge you, and it looks like you rose to the challenge. Does anyone want to share something else they did, or maybe you've displayed it differently?
I did the same thing, but like I started from point P and I made like a Cartesian plane sort of thing.
Okay.
And then I like found out where the first one was on the line, where I put it, and then I did that with the other ones too. So like point P is the starting middle point, sort of.
So I'm seeing something else here. I've noticed, and I'm going to write on your work if that's okay with you. Is it okay?
Yeah.
Don't go anywhere. I need you now. Okay, so you drew a Cartesian plane. The Cartesian plane, I did not include a Cartesian plane today because this is a little more advanced, because I wanted to ensure that you knew how to rotate them outside of the point. Grade 7s, you are more responsible for, your expectations are that you're rotating it where the shape might have been, just say we're rotating, I don't know, a paper clip, whatever. And if you were rotating it here, and the point was there, it would go into all 4 quadrants or more than one quadrant. It's not an expectation in grade 6. That's why I didn't include the Cartesian plane. But all these things happen on a Cartesian plane, if you want them to. But back to me marking up your work here. If we look at the original, let's look at the original. Okay. And let's look at this group's, what they did here. Do you notice a difference between, say, this here and what I drew here? There's a slight difference here. Who's saying?
She drew the line connecting the nearest point to point P to the point.
Yeah, you're absolutely right. She connected it. See this here? It's not over here. It's not connected. But this is, she connected it. Why do you think she did that? Any ideas? Seems odd that she would connect it. Miriam?
Maybe she just thought she could draw the angle.
Draw the angle, okay. Any other guesses? Tim?
Make it easier
Easier for what?
to draw out.
To draw out, okay. I know what you're trying to say. I cut out a replica or like an image of what this group did here. And it looks like this. I've included the connector. Okay, so it would be like this. If I'm to rotate this 90 degrees, my turning points here, I'm going to leave my pen right here just to make it easier. So if I rotate this, it's going to end up here. If this didn't include the connector, so if you cut out your shapes and include and do this, you get a better visual of how it would look like. Okay? So I know the connector, it doesn't seem very natural, but it kind of helps see where the turns will end up. Yes, Tim?
Can you just connect with the shapes and after that move them apart two spaces, two squares?
And you know that's one way to do it as well. But watch what happens when I cut off the connector. Cut off the connector. If I were to rotate this, it's not as easy for me to rotate it to end up here, because you're so used to using a point on the shape, it's going to end up here. Okay? Then what are you going to do? You're going to move it two spaces? It's still not.
So you move it down on P, and after that you
So you moved it down to P,
rotate it,
rotated it,
and after that move to
then moved two spaces over. See, that works too, because you have two spaces here. So there's another method to doing something that I never thought about doing. So that's great. That's a great answer. It helps me. You could still do it this way, but this one you have an extra step, which is annoying, because you need to move it down two, but then you have to move it right two. So you kind of slide it. I don't recommend that, because as your transformations get trickier, this is an easy shape to figure out. But other ones, they might be more triangular, maybe awkward, irregular pentagons, irregular hexagons. You know, those shapes become harder to plot on a Cartesian plane, okay, if you do it my way, especially if you do it my way. So we saw two strategies today. We saw with the connectors, we saw Tim's method. Does anyone have anything else to share, because this video is getting too long?
I made a different strategy because you're being asked to rotate the shape by 90 degrees 3 times. I multiplied that and I got 270 degrees in total, so you'll have to rotate counterclockwise by 270 degrees. And I subtracted that. I subtracted 360 by 270 and I got 90 degrees. So I thought a faster way would be if I rotate it clockwise, the opposite way that it actually asked me to rotate by 90 degrees. I would have gotten the answer faster, and I kind of did because I rotated it by this way, and I got the answer.
So my question is, because I'm seeing two images here.
Yeah, that's because it was a possible mistake that you could have made.
Oh, okay, I see that. So your real image is right
Yeah.
here. Let's darken it up, because this is good. This is a great way to do this. Because now that you did that, I actually saw another thing here. I saw this here. And I'm also seeing that the 180 is pretty evident too, like it's on the opposite side. So if you draw one, you know it's on the opposite side of the other one too.
Yeah.
So maybe going in that order might not work out for you. Great thinking. Maybe you chunked it into manageable ways for you. I like how you've explained here, you may accidentally rotate this way. This actually, what Ilyas did here, is one of the most common mistakes I've seen in transformational geometry. Whereas this shape ends up on top of the line here. Or sometimes it even ends up the opposite way. Let me see if I still have my shape. Here it is. It actually ends up, for some students, they end up doing this here. They put it like this, which doesn't really follow a rotational pattern. You know, that's when I know a student doesn't understand the topic. Okay, that's my clue. But yeah, like this is a common mistake. If you made this mistake on your paper, you're close. Okay, it just has to be under the axis. You can always turn it to see what it looks like. It's under the axis here, and when you turn it this way, it needs to be under here. So the one thing I like about geometry is you can flipping the page like this is definitely, if you're rotating the page, see, I did a 360 turn, huh? Right. So another thing I wanted to show you, just a little trick, is if you have a protractor and to flip it 90 degrees, see this here? This is 90 degrees. So you've turned it 90 degrees. 180 degrees is along the line here. And for 270, I have this special protractor here. My advice is don't get too worked up over 270 degrees clockwise. If they say 270 degrees clockwise, what else can you change it to make it easier? Because 270 means 3 turns. Like if you start here, here's 90, 180, and then 270. What else can we say that's a little bit easier, Maher? Sorry? You can say 3/4 because that's what 270 degrees is. But instead of saying 270 degrees clockwise, what's another, or 3/4 turn clockwise? What else can we say? Because maybe 3 turns is confusing. I would be confused too if I was asked to do something 3 times. 1, 2, 3. I might get lost. What else can we say instead of 3/4 turn or 270 degrees clockwise? Right, you could go 90 degrees or a quarter turn counterclockwise because they're equivalent. They're exactly the same. Okay? And we know 180 is 180, whether it's clockwise or counterclockwise. It doesn't matter how they ask you to turn it. But 270, as soon as you see 270, my recommendation is change it to 90, go the opposite direction. 1 turn, easier than 3.